Hello, everybody. My name is Grupe. I'm one of the astrophysicists here at the Space Science Center at Morehead State University. And I would like to talk with you guys a little bit today about our space system engineering program. Now, when you hear space system engineering, what does it involve? Well, we are building parts for something in space, right? I mean, you know about aerospace engineering, well, that deals with aircrafts. And what we are doing is we are doing the space component of this. And when you think about this, well, you probably think about, well, satellites, these are these big things as big as a minivan or something like this. Well, the ones we are building are much, much smaller. And in a matter of fact, I have one satellite here. This is CXBN. That's a satellite that we launched in 2012. And our students designed it, they built it. And once it was launched, I'm sitting here in the control room of the 21-meter antenna. We can also control the satellite. We have our own ground station here. And every component that you see on the big satellites, so you see always power, you see a radio. Without the radio, you cannot talk to anybody. We have a computer on board, a magnetocoil here that's the attitude control system where we can move the satellite in the Earth magnetic field. We also know where we are in space because we have little sensors here, star sensors, and we have also a magnetotalker like on your smartphone, so you know where you are. And then last but not least, we also have the payload, what we call the payload in our case. This is an X-ray detector, similar to the X-ray detector that your dentist is using when you get your teeth X-rayed. So our students built this, and it's a hand-on thing. It's hands-on. It's a hands-on course, or hands-on courses that you will be taking here. Currently, we are building a very big mission. That's the one right behind me. That's Lunar Ice Cube. And the size of the satellite is exactly that. It's as big as a shoebox. It's about 37 by 23 by 10 centimeters large. And this will go to the moon. That's why it's called Lunar Ice Cube. It will look for the transportation mechanism of water on the moon. Now, why do we care? Well, we will bring astronauts back to the moon, right? And what do you guys need most besides wireless internet? Well, you need water, right? You need water. And so you can either bring the water to the moon. That's very costly, because if you bring a gallon to the moon, that is about, give or take, $100,000. If you, however, are able to mine the water on the moon, well, that makes it much cheaper. Now, the other thing is the moon is just a stepping stool for us to go further onto Mars. And for this purpose, well, we need rocket fuel, right? Well, if you have water, well, you can split water into hydrogen and oxygen, and there we go. There's your rocket fuel. And we can fuel at the new space station up there at the Gateway Station. We can fuel up a rocket and then launch from there to Mars, which is much easier to get away than getting away from Earth. So that's what we are doing here. This mission is currently built down in our clean room. We have also a clean room downstairs where we can build this. So we basically do everything in-house. We build the components if we can. Now for Lunar Ice Cube, this is a little bit different. This is coming from a lot of external vendors. But we mount this satellite together right now. It will be flown on the Space Launch System, on NASA's most powerful rocket ever built. And when it will do the test run with the Orion capsule, this is now planned probably about 1.5 to 2 years away from now, 2022 probably, then we will be flying on that rocket. So NASA does its test with the Orion capsule. And what we are doing is we send out the satellite to about a third of the way to the moon, and then we have to make our way out there. It's a very, very innovative mission, and it has a new drive. It is powered by an ion drive, which has never flown on a CubeSat before. And again, our students learn all this. It's a hands-on thing. When you come to us, you will be involved in soldering courses. You will learn about space dynamics. You will learn about astrodynamics, what the orbits are like. Everything basically. So when you go up in the workforce after you're done here in 4 years, or even if you continue with our master's program after 6 years, you're really ready to go into the industry. And if you don't know this, the biggest industry in Kentucky, believe it or not, is the aerospace industry, which primarily means we are talking about aircraft parts. But there is also a larger and larger component of this is the space industry, which is becoming bigger and bigger. And so there is a very, very good job perspective, also well-paid jobs in this kind of field. So please come for us. If you are a high school student, then please train yourself for getting into this program by taking as much math classes and physics classes that you can, because you want to be prepared when you come to us and you want to be involved with these projects right away when you start. Thank you very much. And just watch out. Google us here and send me an email if you're interested talking more with me about this program. Thank you.